All right, welcome everybody to How to Pass the Physics Regents over at physicsvideotutor.com. My name is Guy Howman, and I'll be going through this webinar with you today. And I will also introduce myself a little more formally in just a few minutes. But first, you are in the right place if this is your first, second, or fifth time taking the physics regents. In fact, if you don't know how you're going to pass this physics regents, then you're in the right place. Or if this is your second or if you've taken this before and you failed, if you think the only thing you got right on the physics regents was your name, then you're in the right place too. But some people, though, know that they can pass but could just use some extra help. That's the right place to be as well. And number three, you want to more than just pass, like score an 80 or higher. Well, in this session right now, I'm going to show you how to do all of the above. Okay, so here's why you should stick around. I'm going to show you how to get a guaranteed 65 plus on the physics regents, even if you failed it multiple times before. You'll also learn how to answer the easiest and most commonly asked concepts, including multiple choice and short answer questions. Okay, so here I am. This is me when I used to have hair, but after 13 years of teaching, you tend to lose your hair a little bit. I've been teaching in public schools and private schools for 13 years or so. And as a high school student, I attended Staten Island Tech. In fact, here's a picture of me from like 20 years ago, 1996. And despite those short shorts, it's a very proud moment because that's when my team and I won the New York City Cross Country Championship at Van Cortlandt Park in the Bronx. All right, and then I went on to graduate from SUNY Binghamton, and I currently work at a New York City public high school on Staten Island called Tottenville High School. So last year, I went through 5 different physics regents exams to find the easiest and most commonly asked concepts and put that together into 70 ways to pass the physics regents. In fact, here's what a couple of students said about the videos. Just wanted to let you know I got an 85 on the physics regents. Thanks for all the help your videos got me to pass chem and physics. Dustin also agrees that the physics test was not bad. He believed he passed. The videos absolutely did help to ensure answering many of the same questions on previous regents exams correctly. Okay, so here's how to pass the physics regents. This is from the June 2012 physics regents. It's called a conversion chart, and out of the 85 questions, if you get them all right, you get 100. But to get a 65, you need to answer 50 questions correctly. Now, on the June 2013, same thing, 85 questions gets you 100. But this time you needed 49 points answered correctly to get to a 65. And then on the June 2014, this time you needed 48 points. On the June 2015, also 48 points. And then on the last exam, June 2016, it went back up to 49 to get to a 65. Well, I'm going to make this the goal of the webinar. I will show you how to get at least 50 points. I'm going to go with the higher number, not the 48, not the 49, but with 50 points on the physics region so that you could pass with a minimum grade of a 65. Although some people seem to like getting a grade of a 69 on the physics regions, whatever that means. So what I did was I went through all those exams that I just pointed out, and I wrote down the question number, which topic it corresponds to, and which way number it corresponds to from 70 ways to pass the physics regents. All in all, 81 out of the 85 questions were covered, allowing you to pass with at least a 96. That's like a 30-point cushion. Okay, so even if you get 10 of those wrong, you're still going to pass with more than just a 65. And on the June 2013, same thing. 80 out of 85 questions covered, allowing you to pass with a 96. Again, about a 30-point cushion. On the June 2014, 77 out of 85 questions covered, also about high 20s to low 30 cushion. And then on the June 2015 physics regents, 79 out of 85 questions covered, so you could pass with a 95. Okay, we're talking cushion here. And then on June 2016, again, 76 out of 85 questions. So we're talking a lot of cushion here. But there's something I want to focus on right here. If you take a look at these questions here, let me zoom in for you. If you notice that a lot of these questions, and this is in the short answer section of the exam, in a lot of these questions, you could get more than just 1 point from one of these videos here. In fact, you got 2, 4, 6, 8, 10, and some even have 3 points potential from just one video. So that right there is 13 points from just 6 videos. I want to go ahead and start with here. Well, I'm going to show you way number 9, and then I'll show you the 3 questions, even short answer questions from the June 2016 physics region. So here they are. These have to do with way number 9. And this is a 2 point question, short answer 56, 57, and then 58 is also related to that for 1 more point. Total is 3 points. So we'll come back and read these questions, but first I want to show you the video for way number 9. Way number 9 on how to pass the physics regions. The time of flight for a projectile depends on the vertical component of its motion. Let's see what this means by using the following question from the June 2012 Physics Regents. When the lever is released, ball B will fall straight down, meanwhile ball A will be simultaneously propelled horizontally. Which statement describes the motion that is observed after the lever is released and the balls fall? Since ball A hits the tabletop at the same time as ball B, it didn't matter that ball A was propelled horizontally. The time of flight depends on the vertical component, thanks in part to the acceleration due to gravity. So if we needed to calculate the amount of time that it takes for the ball to fall, or the distance that the ball falls, we can make use of the following formula, where d represents the distance. And because we are focusing on the vertical component, we can replace the a with a g for the acceleration due to gravity, which is a constant 9.81 meters per second squared. Additionally, since objects in the vertical component will most likely be starting from rest, we can automatically get rid of the initial velocity and time to avoid multiplying by 0. So if a rock is dropped from a bridge, what happens to the magnitude of the acceleration and the speed of the rock as it falls? Since gravity is a constant 9.81 meters per second squared, the acceleration will remain the same and the speed will only increase if it is starting from rest. Now that we got that out of the way, let's move on to some calculations like in this question from the June 2009 Physics Regents. To find the total distance the weight falls, simply plug in the values for 1/2 g times t squared and solve, and you will get the correct answer. In this next question, from the June 2011 Physics Regents, they ask, what is the total distance the object falls during the first 3 seconds? While this is another d equals 1/2 g times t squared question, be careful when they say the surface of a planet. By this, they mean that the acceleration due to gravity will be different and can be obtained by looking at the slope of the graph. Choose any set of coordinates to work with and then divide to get the planet's acceleration, which you then substitute into your equation. After squaring and multiplying all of the numbers together, you should get 12 meters as your answer. While this last question from the June 2010 Physics Regents brings us back to Earth, they now want you to calculate the time required for the stone to reach the ground below. Therefore, using the same formula as before, we'll need to rearrange it to get the t by itself. To do that, you simply move the 2 to the top of the other side to get rid of the half. Then, move the g to the bottom of the other side and take the square root of everything to get t by itself. After substituting with units, your work would look like this. After multiplying the numerators together and dividing by the denominator, find the square root of 10.2 and you will arrive at your answer. And don't let that horizontal speed throw you off, since the time of flight depends on the vertical component. All right, back to the questions from the June 2016 Physics Regents. Now, there's a lot of words here and everything, but just to get straight to the point, it's talking about a ball rolling off the table, falling onto the floor. They want to measure the height and the time and all that stuff that's similar to what you saw in the video. So the bottom line here is they want you to calculate the height of the table. All right, so we're going to use this formula right here, and even though it was traveling at 2.5 meters per second when it reaches the edge of the table, that's a horizontal velocity, right? Remember, it's the vertical component that matters here, and so we could eliminate, and that's why we eliminated the initial volume, the initial velocity. And so when you take a look at the answer key, right, for 2 points, you need the equation. So here's the equation, but notice they got rid of VIT because the initial velocity is going to be 0 in the vertical component, and what you're left with is the 1/2 AT squared, or the 1/2 GT squared, which is the acceleration due to gravity, and the time, which they gave you right here, squared. And so when you do the math, you end up with 0.750 meters, and that right there gets you the 2 points. So when they're dealing with height, table, balls rolling off the table, things like that, you want to go with this formula right here, 1/2 GT squared. And then for the next point, the third point, in trial B, the ball is traveling at a faster speed when it reaches the edge of the table. But it doesn't matter if it's going faster or slower, the time it takes the ball to reach the floor is going to be the same. Okay, it's going to be the same. And so the time depends on the vertical component, not the horizontal speeds or anything like that. And so that goes to show you that you could get 3 points from just one video. In the next situation, it looks like we have a multiple choice question and a short answer question, both of which could be answered using way number 16. Okay, it looks like it has to do with weight and mass and acceleration due to gravity. So let me show you the video for way number 16, and then we'll come back and I'll show you how to quickly and confidently answer these questions. Way number 16 on how to pass the physics regents. Weight is nothing more than the mass of an object multiplied by the acceleration due to gravity, according to the following formula where the m and the g are cross multiplied. So, any idea what the weight of a 2 kilogram object will be on the surface of Earth? Just plug in the mass and the acceleration due to gravity and you will get the correct answer. In fact, if a rock is thrown straight up into the air, the magnitude of the net force acting on the rock at its highest point is the same as the magnitude of the rock's weight. But if a student is standing in an elevator that is accelerating downward, then the force that the student exerts on the floor of the elevator must be less than the weight of the student when at rest. So while the weight of an object can change, the mass of the object remains the same. All right, coming back to these two questions from the June 2016 physics regents having to do with weight and mass and gravity. And question 2 here, it says a 65 kilogram astronaut weighs 638 newtons at the surface of Earth. What is the mass of the astronaut at the surface of the moon where the acceleration due to gravity is different? Okay, now remember, gravity can change, but the mass stays the same. And so if the mass of the astronaut is 65 kilograms on Earth, then the mass of the astronaut on the moon is the same as 65 kilograms. So be aware that they might ask you about the gravity, they might ask you about the mass, or they might ask you about the weight. In fact, in the short answer question, the graph below represents the relationship between weight and mass for objects on the surface of planet X. Determine the acceleration due to gravity on the surface of the planet. So if you go back to this formula here, the acceleration due to gravity is nothing more than the force due to gravity, which is weight, measured in newtons, divided by mass. So you could take any values from the weight and divide it by the mass, and you get your answer. 18 divided by 6 is 3. 12 divided by 4 is 3. 6 divided by 2 is 3. And f of g divided by m is the acceleration due to gravity. Once again, showing you how you could get 2 points just from one video. Moving along here to this next question from the June 2016 has to do with way number 18. So let me show you the video for way number 18 and then we'll come back and answer this question quickly and confidently. Way number 18 on how to pass the physics regents. Questions regarding the magnitude of gravitational force come up on every single exam and sometimes even more than once. And despite this crazy looking formula, there is one relationship that you absolutely positively want to be familiar with. The magnitude of gravitational force has an inverse square relationship with distance. This relationship even holds true for electrostatic forces. Do you see any similarities? And that's why you should already know the answer to this question before it even has a chance to finish coming onto the screen. If you pick choice 1, you'd be correct. Now here's a hypothetical example of the relationship that exists between the gravitational force and radius using really easy numbers. When the radius is 2, the magnitude of the gravitational force will also be 2. But when the radius is doubled, the magnitude of the gravitational force is reduced by 4 times as much thanks to the inverse square relationship. And the opposite is true as well, like in this question from the June 2009 Physics Regents. When Earth and Moon are separated by a distance of 3.84 times 10 to the 8 meters, the magnitude of the gravitational force of attraction between them is 2 times 10 to the 20 newtons. What would be the magnitude of this gravitational force of attraction if Earth and the Moon were separated by a distance of 1.92 times 10 to the 8 meters? Since the radius was cut in half, the magnitude of the gravitational force will need to be 4 times as much, and it is. Now here's another question from the same exact regents that is pretty much asking about the same relationship, and it might even look like something else you've seen before. It starts off with a distance of 1 meter, but then the distance between the spheres is increased to 3 meters, or 3 times as much. And thanks again to the inverse square relationship, both FG and FE will be reduced by 9 times as much. All right, coming back to this question from the June 2016 Physics Regents. This one deals with electrical force. As you saw in the video, it could be dealt with gravitational force or electrical force. Both have the same formula and work the same way. And so if we have a force of 8 newtons here, and the 2-point charges are Q1, Q2, and it says if the distance between the charges is doubled, well, the force will be reduced by 4 times as much. That's the inverse square relationship. So 8 divided by 4 gives us an answer of 2. And then on the June 2015 Physics Regents, I just wanted to check, and there was a similar question, but this time the distance was tripled, just like you saw in the video, making the force get reduced by 9 times as much. So you like to see here how we get 1 point from one video. Gravitational force or electrical force, same formula. They like to double, they like to triple, but the inverse square relationship works the same way for both. So we're going to move along here to the next concept, which looks like you could get 3 questions from the same video, which is going to be way number 50. So I'll show you that, and then we'll come back to answer these questions quickly and confidently. And by the way, it has to do with the waves. So way number 50 on how to pass the physics regents. There are 2 main wave types that you should be familiar with, and they are electromagnetic waves and mechanical waves. Let's use the following question from the June 2013 Physics Regents to compare and contrast these 2 wave types. Choice 1 is incorrect because electromagnetic waves travel very fast like light, whereas mechanical waves move slower like sound. As further proof, here are the speeds of both light and sound as found on the physics reference tables. At first glance, their speeds look pretty comparable, but when you look at the exponents, the speed of light is 1,000,000 times faster than the speed of sound. By the way, visible light makes up only a small sliver of the entire electromagnetic spectrum. You should also know that in a vacuum, all electromagnetic waves have the same speed, which brings us to the next difference between electromagnetic and mechanical waves. Choice 2 is incorrect because electromagnetic waves do not require a medium for propagation, whereas mechanical waves do. That's what this is referring to over here, making choice 3 incorrect as well. So, which type of wave requires a material medium through which to travel? Hopefully you pick sound, especially since the other three choices are all different forms of electromagnetic waves. Clearly, the one thing that both type of waves have in common is that they can transfer energy and information, but not mass, and that also applies to a pulse, which is an individual wave. The way they transfer their energy, though, is done in different ways, which will be covered in another video. So, to sum it all up with this question from the June 2012 Physics Regents, what is characteristic of both sound waves and electromagnetic waves? They both transfer energy. All right, coming back to these three questions from the June 2016 Physics Regents, all having to do with way number 50. And we'll start with this question right here because it's going to be a dead giveaway. A light wave strikes the moon and reflects toward Earth. As the light wave travels from the moon toward Earth, the wave carries, I think it's clear that it's energy only. All right, just so you know, matter and mass are kind of one of the same in the sense that all matter has mass. Okay, and so waves can only transfer energy and information, but not mass. And we made it clear in the video that it's energy only. All right. Question 6 over here. Sound waves. Well, sound waves are mechanical wave types and they are longitudinal. So that right there is the answer. So you just want to see that they repeat these same questions over and over again. Now with question 27, they talk about gamma ray traveling in a vacuum and a microwave traveling in a vacuum. So, and they're asking about wavelength and energy. So you might want to check the electromagnetic spectrum in the reference table here. Gamma rays are right here, microwaves are over here, and because they're asking about the wavelength, wavelength is on top. And notice, these exponents here are negative, and as the negative exponent gets higher and higher, the wavelength gets smaller and smaller. So compared to the wavelength and energy of the gamma ray photon, the microwave photon, so they're asking about this compared to that, and because these are smaller numbers, that means the wavelength will be longer. We could eliminate 1 and 2, and if the wavelength is longer, then a little tidbit of information for you is that it will have less energy. The shorter the wavelength, the more energy, or the longer the wavelength, the less energy. So we're going to go with choice 3 here. Once again, 3 points from one video. All right, moving along here to this next question from the June 2016 Physics Regents. Actually, way number 56 was not on the June 2016 Physics Regents, but I want to show it to you anyway because I have a strong feeling that it's going to be on the next exam, and you'll see why in a second. So let's take a look at the video for way number 56. Way number 56 on how to pass the Physics Regents. Sound waves strike a glass and cause it to shatter. This phenomenon illustrates the concept of resonance. Resonance is a phenomenon in which energy is transferred from one system to another, a concept that is asked about on pretty much every physics exam. Playing a certain musical note on a trumpet causes the spring on the bottom of a nearby snare drum to vibrate. This phenomenon is an example of resonance. When the medical technique known as ultrasound is used to shatter kidney stones, it is an application of the phenomenon known as resonance. And if they mention something about one tuning fork transferring energy to another, causing the other tuning fork to vibrate, they are most likely talking about the phenomenon known as resonance. So that right there was way number 56 on how to pass the Physics Regents. So take a look. June 2014, June 2015. If you go back here for a second, notice you're looking at questions that was 30, 29, 25, 32, 32. So guess where these questions are going to fall on the Regents exam? Well, uh, besides the question number, you're looking at phenomenon. That's going to be a giveaway. Okay. And then the question number there, right in the high 20s, both of which were number 27, you're going to be looking for resonance. Okay. And even if you go back 10 years, June 2004, and then June 2007, January 2007, questions 28, 29, all the same region. They all mention phenomenon and they all deal with resonance. Okay? So Gianna sent me an email after the physics regents in June saying, I feel I passed my physics regent because of just watching the webinar. Everything you basically explained was on the regent, including the phenomenon question. Last year I watched the chemistry video and I swear that was the only reason why I passed. Thank you. So far on the June 2016 Physics Regents, I've showed you how to get 9 points from just 5 videos. We still need 41 more points so you can pass with a 65, but we have 65 videos left to go. But I value your time. So you have two choices. Number one, you can go into the exam with what I've shown you today in the hopes that you pass, or you can watch the entire 70 Ways to Pass the Physics Regents video series and get a guaranteed 65 plus. And I put the word guaranteed in capital letters, and I'm even going to underline it 5 times. Here's why. On the last 5 Physics Regents exams, there have been at least 70 plus questions covered by 70 Ways to Pass the Physics Regents, so you can score more than just a 65. In fact, it's not unheard of to get an 81. My son did more than just pass. A few weeks ago, I was worried that my son wouldn't pass the physics region, so we bought this course. Not only did he pass, but he got an 81. Physics was a huge thorn in our side this entire school year, so this is a huge accomplishment. All right, so there's stories like that. But now it's your turn. But before I tell you more about 70 ways to pass the physics regents, I want to tell you what it's not. You're not going to be sitting in a classroom all day for 7 hours. You're also not going to be paying a very expensive fee for a course that's not even refundable in the event that you fail. But with 70 ways to pass the physics regents, you can get through the entire video series in just a few hours, and you'll have access for 11 months. And for a fraction of the cost of a crash course, on top of the fact that it comes with a 100% money back guarantee. You see, a crash course is not going to give your money back in the event that you fail. A private tutor is not going to give you money back in the event that you fail, but I will. Here's how the guarantee works. If after watching 70 Ways to Pass the Physics Regents in its entirety, you end up failing the Physics Regents, simply email us your failing grade along with your certificate of completion, which you get upon completion of watching the entire video series, and we will gladly refund 100% of your purchase price. So head on over to physicsvideotutor.com/70 ways to sign up for 70 Ways to Pass the Physics Regents, and I hope to see you on the other side. Either way, I wish you the best of luck on your physics regents. Take care, have a great day, and thank you for watching.